For our next topic in quadratic relations, we're going to continue working with graphing things in what's called vertex form. Last lesson we looked at ax squared plus k. Today we're going to look at a variation on that, a, and then in brackets x minus h, and then the squared on the brackets. So we're going to still be using a. That would, remember, it gave us the direction of opening and the vertical shift, but sorry, not the vertical shift, the direction of opening and the vertical stretch or compression. We're going to not worry about vertical shifts today, but we're going to add in something, a letter H, which will actually give us a horizontal shift. So there's two important things to know about H. So again, H it's never going to be a letter when we look at it in an actual question. It's going to be a number, and it's going to tell us our horizontal shift. So the two important things we need to know are, first of all, it tells you how far to move the vertex to the left or right, horizontal, right? And the other important thing that you need to know is that it's opposite of what you would expect. So let's go back to k for a second. That was the up or down one. If k was a plus 3, we would move up by 3. That makes sense. If k was a negative 3, we would move down by 3. That also makes logical sense. H is kind of counterintuitive. If we see an equation where h is plus 3, so inside the brackets say we had x plus 3, we would probably think that we should move to the right, because that's what we're used to. But this is actually the opposite. So if we had x plus 3 inside these brackets, we're actually going to move to the left. And if we have a negative inside the brackets, we're going to move to the right. So, for each dark-lined parabola, identify the value of h and the coordinates of the vertex. All right, so these are, again, horizontal ones. So horizontally, well, actually, look at the dark graph. It looks like it's been moved to the left compared to the lighter graph. So we know, again, that this graph, let's zoom in a bit, this graph is y equals x squared. And this is something else. The darker one is something else, and we could come up with the equation with that. We will later, but for now, let's just worry about the vertex. Remember, the vertex is that highest or lowest point. So that's the vertex. So the vertex is there. So we want to identify the value of h and the coordinates of the vertex. Let's start with the coordinates of the vertex. That's the easiest. So the vertex has got an x value of -1 and a y value of 0. All right, I'm just reading that off the graph. It's kind of hard to read the scale, but you know, if you count it out, you can see that x coordinate is -1, y coordinate is 0. That's my vertex. That's where the maximum or minimum point is. And so that's that. The h value is simply the x coordinate of the vertex. So it's -1. It doesn't matter that this parabola opens up. That's got nothing to do with the h value. It's got nothing to do with the vertex. Just like for this one opening down, that has no effect on anything that matters for this question. The vertex is right here. It's the highest point in this case. The vertex is +6, 0, and the h value is just the x coordinate of the vertex, so it's +6. Describe the shape and position of each solid parabola relative to the graph of y equals x squared in terms of a and h. All right, so again, here is y equals x squared. That's this one. So we want to say what's happened to the darker one compared to y equals x squared, the lighter one. So the shape, it looks like it's been vertically stretched. Right? That darker one looks skinnier than the lighter one, which only comes from vertically stretching. And if that's the case, then we know that our a value must be some value bigger than 0. We don't know exactly what it is. We could figure it out, but that's not our concern at the moment. We just know that actually not even bigger than 0, bigger than 1 is what I should say. Our a value is greater than 1 in order to vertically stretch it. As for the position, it's been shifted right. In other words, the dark one, if I took the light one, my original, my starting one, and moved it to the right, and I got the dark one. So I imagine the way I describe it is if I was starting with the light one, then how did I get to the dark one? So we shifted the original graph to the right. In the second example here, then it's vertically compressed. I know that because the darker one looks wider compared to the original graph of y equals x squared. So that makes it vertically compressed, and it's been shifted, and sorry, I might as well just say that a is less than 1. In other words, it's a fraction. It's actually going to be a negative a value, but I'm not even worrying about that right now. It's a number between 0 and 1, and it'll be a negative number. And this one's been shifted left. I can say how far each of these are as well. I know that this one's been shifted left by 3 units. And the reason why it's 3 units is because the vertex is at -3 on the x-axis. This one, the vertex is on +1, so I know it's been shifted right 1. Neatly sketch each graph. All right, no problem. Start with the vertex for a part. So the vertex starts out, we always begin by thinking about the vertex at 0, 0. But because of this k value, h, k was yesterday. Let's use blue pen. I don't want red. So because of this h value, remember that's always the opposites. The h value is actually -4. So when I look at this sign, I always change the sign, and I'm going to shift it left. So my h value is -4, and so my vertex is going to shift 4 to the left, and so it's no longer at the vertex, it's no longer at the origin, it's now at -4, 0. And then I'm going to use my step pattern. Remember that? So the step pattern, the basic step pattern, was 1, 3, 5, all the odd numbers. And finally, I need to consider the fact that this a value is negative, so it opens downwards. So from that vertex, I'm going to go downwards. So I'll follow the step pattern going downwards from -4, 0. So I'll go 1 over and down 1. Then my next step will be over 1 and down 3. Then my next step is over 1, down 5. My next step would be over 1, down 7, but I don't have any more room. Then it's symmetrical, so I'm just going to make a mirror image of those points to complete my U shape, and this was part A. There we have the graph. Okay, let's do part B. This one's got its vertex, well, the h value anyway is +2, because again I'm going to change that negative sign to a positive sign, so the vertex moves over to +2, 0. And then if I look at the a value, it's positive, so that opens up, but it's also a 2, so that means I'm going to double my step pattern. So the step pattern is going to become double. What does that mean? Well, that means it's going to become 2, 6, 10, 14, and so on, if I had more room, because I'm doubling the 1, 3, 5, 7. So I'm going to go over 1 from the vertex and go up by 2 for my first step. Then I'm going to go over 1, and I'm going to go up 6 from that step. And again, now I've run out of room. So I'll just do my symmetry, get my U shape, and you can see that I'm able to graph these really quickly. So that's a nice thing. If you know the step pattern, you know what A and K and H mean, then you can graph them pretty quickly. Example 3. In each case, the parabola y equals x squared, our basic parabola, is transformed as indicated. Write the equation of the new parabola in this form here, y equals ax minus h squared. It's reflected in the x-axis and shifted 3 units to the left. All right, so let's think about that in terms of what the values are. If it's reflected in the x-axis, that means that a is negative. It doesn't say anything about a stretch, so we won't say anything about stretching it. We'll just assume that it's still 1. That won't stretch it. That'll keep the same shape, but we have to make it a negative 1 to reflect it in the x-axis. And shifting it 3 units to the left, that means that h equals negative 3. But then, when I put it into the equation, now I'm going to put it into this equation, when I stick those values in, the h will change signs. What's really happening, oops, that shouldn't be an a there. I should have a negative 1, right? I'm going to stick these numbers into these positions here. So when I stick those numbers in, I'll get negative 1 x minus negative 3 squared. So I'm going to replace those a and h values with negative 1 and negative 3. And again, what happens? Well, these two negative signs here in front of the 3 become combined into one positive. So it becomes x plus 3, and that would be the equation. So what you need to know is that whatever your h value is of your vertex, change the sign when you put it into the equation. Compressed by a factor of 0.5, okay, a equals 0.5. Shifted 8 units to the right, h equals 8. Y equals a times x minus h squared. So let's plug those numbers in. 0.5 goes here. 8 goes in here. We're done. Again, it's quick. It can be anyway. And that is the end of that lesson.